So in this video here I'm going to go through the 2021 B2 intersecting planes question. It tells us the image on the right shows a car showroom in Qatar. The building includes a series of intersecting planar triangular surfaces. Figure B2 shows the plan and elevation of four intersecting triangular planes. The horizontal and vertical coordinates of points A, B, C, D and E are given. Partial coordinates of point F are also given. So you can see all your coordinates there, and then we're missing the X and the Z coordinate. So X we know is the distance going across, Y is the distance going up, and Z is going to be the distance going down from our XY line. So we need to get our X and our Z then later on. For part A it says draw the given elevation and plan of the intersecting planes ABC, ABD and BDE. Part B, determine the dihedral angle between the planes ABC and ABD. So we see what's common between the two, AB and AB. So when we find AB here, we're going to be taking an auxiliary view. So for this question I'm going to take an auxiliary view going out this way to the left, and then I'm going to have a second auxiliary going further out to the left then. So just thinking already about where to position the question. At the moment we could keep this to maybe the top right of the page, so we have space to the left and below for the auxiliary views. Part C then, a line is drawn from the point E. The line is parallel to the line AC and intersects the horizontal plane at a point P. So for this part here, we're going to be taking a line from E parallel to AC. So it's going to be a line going out here, so once again it's going off to the left. So we want to keep room to the left hand side then, so nothing else going on the right yet. And we're going to do the exact same plan in order to find out the true inclination that line makes. Then part D tells us to draw the true lengths of the edges AF and CF are of the plane ACF are 70 mm and 80 mm. So telling you the true lengths of AF, that line there, and CF, that line there, they're 70 mm and 80 mm respectively. So AF is going to be 70 and CF is going to be 80. Complete the projections of the triangle ACF. So we have to use these measurements in order to get our last point here. We already have the height of it, but we need to use this information to work out how far across it is and how far down it is. So for this question here, I'm going to keep it near the top left because I know there's nothing going above it. So in terms of my Y coordinates, my distance going up, the highest point I have is going to be 90 mm up. So with that in mind, I could take a line down here and say it could be roughly 110. Gives me 20 mm space then as a result. And just take my XY line across there. For my X coordinates, the furthest point is going to be 180. So I know there's nothing really going to go on the right hand side. So I can maybe start around here potentially and mark that as my 0 coordinate. So I'll leave a little bit of space in case I do need it later on the question for part D when I'm trying to figure out where point F is. Excuse me. So for my points A, B, C, D, E, my first one, A is over 145. And I'm going up 10 and down 70. Same for point B, it's across 130. And it's up 45 and down 40. Then C is going to be 180, 55 and 30. So I already have my 180 there. So there's C, and then D is going to be 100, 60 and 20. And then 20 down there. And E is 1, 4, 5, 90 and 10. So I already have 1, 4, 5 that was used for A. So go up 90 and then down 10. And then F is just up 10, which I already have marked off for A. So what I can do is I can extend it across for now. It's going to be out here somewhere later on in the question. Next thing is connect all my planes together. So ABC is a plane. And then we have a plane ABD. And then we have a plane BDE. And then BDE there. So that there is part part A. So part A is what we've just done there. So one second, just pause it, just try and get rid of that light there blocking the sheet. That should be a lot better. Now for part B. Part B there tells us to determine the dihedral angle between the planes ABC and ABD. Where we determined that the common thing between the two is AB there. So my first auxiliary is going to go out here, the second one is going to go out here somewhere. So when we're taking auxiliaries, we always go 2 views back. So there's A and B, and then C and point D. Here we have our x1, y1. I'll just extend these points out a bit further for any heights that are longer than the ones I've given there. Right. So 2 views back, 1 view, 2 views. So I need point A, B, C and D. A is my shortest one, the 10. Follow it down, follow it out. There's point A. Point B, follow it down, follow it out. Point C is this height there. Follow it down, follow it out. And then point D is this height there. Follow it down and follow it out. And the key thing I'm going to get from this is when I connect A to B, that's going to be the true length of AB. So A and B connect together, and then B and C, and then it is A, B and D. Now I want to look along AB, because I want to see it as a point view to get the dihedral angle in between. And C, and D. And then I'm going to create a second auxiliary. X2, Y2. One view back, two views back. So I'm measuring from my X1, Y1 back into my plan. You'll notice that A and B, they're the same distance. So we're going to see it as a point view. So there's points A and B. Then for C, it's going to be this distance here. Follow it down, follow it out. And then point D is going to be that distance there, follow it down and follow it out. There's plane ABD as an edge view, and there's plane ABC as an edge view. And in terms of the dihedral angle then, just to measure it, if I just extend my line out here and my line out there, just to get my angle, you'll see that it's going to be 164 degrees. So 164 degrees is my angle there. And that now is part B complete. Part C then tells you a line is drawn from the point E. This line is parallel to line AC and intersects the horizontal plane at a point P. So it's a line drawn from E parallel to AC. There's AC. Slide across to E. Take it down. It hits the ground at point P there. We do the exact same thing in plan then. We go to AC, parallel from E. We know where it stops on the ground there, so all we do is drop this line down to see where it intersects. Then we can see the plan view of that. There's our point P, so I'll just use a colour for that. So there's the elevation of that line there. There's the plan of it. We want to find the true inclination. This is going to be the exact same method. So what I was saying there was basically to get the true angle, it's the same method that we would use when we're finding, say, the true length of a line. What we want to do with this line here is rotate it around until it's parallel with the XY line. If the line is parallel with the XY line and we take it up and connect it back, we're going to see not only the true length but the true angle the line makes with the horizontal plane. So if you imagine like a pencil like this, it's up there and you want to see that angle looking in there. What you could do is rotate it around so it's right in front of you, and when you look straight in at your elevation, you're going to see that angle the pencil makes with it. So we're going to leave E as our fixed point, that doesn't move. So you can line across parallel to XY line. We stretch our compass out to P, rotate it around. Where it crosses where E is there, going across, we take it up. There's the height of P in elevation, it's on the ground. So if I want to draw my XY line in heavy there. And then connect E out to our new position where P is, and that gives us our angle that our plane makes. And then all I need to do is measure that angle. So it makes an angle of 39 to 40 degrees roughly. So it's closer to 40 for me there. So 40 degrees is the angle that that line makes with the horizontal plane. And that's now part C complete. Part D then asks you, it says the true lengths of the edges AF and CF of the plane ACF are 70mm and 80mm. Complete the projection of the triangle ACF. So we already know the height of it. But we now know that the length of AF is 70mm and CF is 80mm. So they're true lengths. So first thing we need to do is, we know the length, for example, of CF is going to be 80. F is on this height off the ground. If we take 80mm on our compass and swing from C, that distance from there to there, that's a true length of 80mm. And what we're doing is we're working backwards. We're showing that's going to be our true length. We know the height of F. It's going to be somewhere along that line, but if we took the true length of it, it would hit it there. If you think about it, that's the true length of a line. In the opposite view, that line will appear parallel to XY line. We take it down. We take that across. There is that point, the end of that line in our plan view in parallel. Remember, a line parallel to XY line is a true length. All we've done is worked backwards with this. Now F, we can see in the question, is somewhere down here. So what we can do then is, we can take that length, rotate it around. We don't know where it's going to stop yet, but we can rotate that distance. We know that AF is going to be 70mm in length. And with this line here, A to F is going to be a horizontal line. It's going to be parallel to XY line. So that means we can swing a 70mm distance from A and use it as the true length. So 70mm from A crosses over at that point there. And that gives us F. So, because remember, A to F is going to be a horizontal line there. It's parallel to XY line. Therefore, AF in plan is going to be a true length, which we know is 70. When I swung that 70mm line, or that 70mm arc, it crossed over our one already that we had for 80. That gives us point F there. We can connect those together. So we know that's going to be 70. Now we can take that up to give us point F there. And now we have ACF, which completes part D of the question.